All right, so let's learn up what is the mass balance concept. What that means is in a green infrastructures, how much pollutants move into the system should be predicted as what's the pollutant leaving the system plus the pollutants reacted or removed in the system. So mass in equal to mass out plus mass removed. Um, and when the pollutants is created in the system, sometimes green infrastructure could also produce pollutants. For instance, nitrogen ammonia can be reacted in the system and produce nitrate. In this case, nitrate is being produced. Um, so this is what we can do that. So that means you can write dm by dt coming in equal to dm by dt amount of pollutants leaving the system plus amount of pollutants removed outflow. This is outflow, inflow, and removed. And that removed could be because of reactions, many kind of reaction. And this reaction could be absorption, degradations, and all these things settling, everything that we discussed before. So all the reaction combined together, we can say that this is being removed. So as long as you know how to express them, that will determines the and the in the equilibrium or when there is steady state condition, this is the equal to same thing. But if it's not, then you can the difference is what the pollutants is being accumulated in the system. So that means that you can write dm by dt accumulations accumulations or how much pollutants accumulate in the green infrastructure. If it's not degraded, then this is equal to dm by dt coming in minus dm by dt out minus dm by dt react. So if you add them all together, then you will calculate how much pollutant accumulate in the system over time. And this is important because that will determine how long the green infrastructure will last before this will not be able to remove any pollutants. And so for the mass balance of the pollutants, there are, you can also predict the mass balance of water, how much water is being passed through the system. So this is just, I want to show that the mass of water is basically the density times volume of water, and then density is constant in most cases. So that means this is density times dV by dt. So when you are solving for volume of water capture, then you can use this concept for mass balance for water. But whereas the pollutants is mostly moved by water because the pollutant dissolve in water. So mass of pollutants entering into a system is basically concentration times the volume of water. And if the concentration is constant, then you can say that this is a rate of change of water being added to the system or removed from the system, which is basically definition of flow rate. So mass of pollutant removed in the system or added in the system is basically um, the flow rate times the concentrations. So if you know this factor, then you can solve for these equations that I wrote here. So let's solve for one of the estimating change in volume, which is one of the things that you can predict how much water is being captured. So based on that, you can know that if the pond is there with a volume of change in water volume, so that means it's basically dV by dt, which is the change in water volume, is basically difference in flow rate. This is Q in, this is Q out. So the difference in flow rate will predict how much volume of water is being captured. So if you solve this one, dV Q in minus Q times dt, and integrating with the in the boundary conditions where the initial volume was V0 and the final volume was V, one time equal to 0, time equal to T. So then you can dV, then integration is this by this. So what that means, you can use these equations, here is you can use this equation to predict the change in volume or the amount of water in the system at any time. So what that means is the amount of water in the system at any time is equal to the amount of amount of water that was there before you start counting or start estimating, and difference in flow rate times the time. This is basically amount of extra work entering the system, net amount of work, because this is the Q in times T is the amount of work coming in, Q out times T is the amount of work leaving the system. The difference is the amount of work that remain in the system to increase the volume. So with that, you can solve questions. For instance, here a retention pond receive wet weather runoff of 20 meter cube per minute after rainfall. The site manager opens the gate to discharge water at 10 cubic meter per minute. If the initial water depth of the pond is 0.5 meter, what would be the depth of water after 1 hour of rainfall of runoff? So again, think of what is there. The detention pond is given. The area is given. That area is 100 times 20 meters, so that's basically to 2000 meter square, and your flow rate is 20 cubic meter per minute. This is 10 cubic meter per minute, and that's the flow Q in, and this is Q out. And it's saying that your initial water depth is 0.5. What will be the depth of water after 1 hour? So that means all you have to do is you have to calculate how much water is going to accumulate in that 1 hour. If you know that one, you know how much height is going to reach. So basically, the initial height was 0.5 meter, 0.5 meters. As the water rise, it is going to rise even more based on the volume. So what that means is the height of the water is basically the volume of water, how much volume you added divided by the area. If you think of a cylinder, the height times the area is the amount of volume of water. And the change in volume of water, you know that based on these equations, change in volume is a difference in flow rate times. So that is basically Q0 minus Q, or Q in minus Q out times time the amount of volume increased. Um, that's basically the amount of height. That's basically amount of height increased and divided by area, and that's basically it's going to be 20 minus 10 cubic meter per minute times time is 1 hour. 1 hour is 1 hour is the same as 60 minutes divided by area is 2000 meters square. So that is basically 10 times 60, 10 times 60 divided by 2000 meter. Everything cancel. You can see hour cancel, minute cancel, meter square cancel. This is meter. So that is 600 divided by 2000. So that will be 3 and 20. So 3 divided by 10. So 0.3 meter. This is the amount of height that will increase. So initially it was 0.5 meters. So the final height will be initial height h0 minus delta h, which is 0.5 meter plus 0.3 meter, which is going to be 0.8 meter. So again, this is the equations you can use to predict how much water is going to rise. This is the same kind of equations used to predict how much when you have a dam, how much water you can to capture, and if you have to release some amount of water and at what rate. But most of the time, our goal is to determine the concentration of pollutant. So in the next video, we are going to learn how to measure the concentration of pollutant based on the mass balance.